Using matrix inverses to code a message. Coding message we call a cryptogram, which is a message written the way that no one other than intended recipient can understand, right? To encode the message, let's assume we assign numbers to each letter in the alphabet. Let's say our code, the code is going to be A is a 1, B is a 2, C is 3, and all the way Z is 26. And the space is 0. Okay? So let's take example. Let's say we want to encode the word math. If I want to code, it's going to be M is going to be 13, and then A is 1, T is going to be 20, and H is going to be 8. The numerical equivalent of the message is then converted into matrix. Okay, so these numbers we can write down in the format of matrix. And and finally, an invertible matrix can be used to convert the message into code. The multiplicative inverse of the matrix can be used to decode that message. So, first step, we have to, let's work now. The first step is write down the word numerically. We completed this. Yes? The word math we wrote down in the numerical format. Next, we need to represent these numbers in the format of matrix, which is going to be, since we have 4, we are using 2 by 2 matrix. Why we need to use square matrix? Because only square matrices have inverse, right? Okay, so we are writing down 13 and 1, 20, and 8. So we placed into matrix. Now, just in case, let's assume you have the word consists of, I don't know, 19. Yeah? 19 letters, or which means 19 codes. So since it's odd numbers, how are you gonna do it? Then you are going to use 4 by 4, it will not be enough. You are going to use 5 by 5, 25, right? And the places, the spots where you don't have code, you're gonna fill out with 0. That's how you're gonna work on it. Okay? So next step, so we fill out the matrix. Step number 3, we are going to select any square invertible matrix. To remind you, invertible matrix is a square matrix that defined as invertible if the product of the matrix and its inverse is giving you identity matrix. So we need to find the inverse and checking it the original matrix. Let's say original matrix is A, inverse is B. Okay. So if you multiply, you are getting identity n times n, because you have A is n times n, invertible matrix. B is a matrix that is inverse of A. It's also n times A. And identity matrix is also n times n. So identity matrix, to refresh your memory, identity matrix is the matrix that by diagonal has ones, and the rest is 0. Okay, here we go, identity matrix. So now let's move on. So we are going to select a square invertible matrix that we call coding matrix. Okay, I'm taking inverse, so -2, -3, 3, and 4. So this is coding matrix. Any coding matrix of the same size of your code, which is 13, 20, and 2 by 2, just like here we have. And as long as it's invertible, you have to check it. If it's invertible, I have checked it. It has the inverse, and you multiply by inverse, you get identity matrix. Then you can use it. So this is our coding matrix. And this one is our numerical representative, right? Numerical representative of the word math. Okay? All right. So let's multiply. Let's see what we are going to get. So we are getting -2 multiplication of matrices times 13. Who doesn't remember, open the video how to multiply matrices. Minus 3 times 1. And then here we are getting -2 times 20 minus 3 times 8. Also 3 times 13 plus 4 times 1, 3 times 20 plus 4 times 8. And as a result, we are getting -29, -64, 43, and 92. So what does that mean? So this using these numbers by column from the coded matrix, we are write down encoded message. So encoded message for the word math is going to be -29, 43, -64, and 92. And this code, these numbers we took from this matrix, is encoded word math. So we encrypt it. All right, now let's decode this word math or message, whatever message you want, and with the space that will be coded as a 0. So let's do the word math and decode it the same way. So we need to find multiplicative inverse of the coding matrix. So the coding matrix we used is this one, right? Coded matrix. So I'm going to take this coding matrix, -2, -3, 3, and 4, okay, and find the inverse of this matrix, okay. Whoever doesn't know, you can look into the video how to find the inverse, but here without explanation I'll just do it real quick, so to refresh your memory. So it's 1 over -2 times 4 minus 3 times -3, okay. And we are switching numbers by diagonal, 4 and -2, and changing by opposite signs, the 3 and -3. -3 comes here and 3 comes here. I didn't switch -3 and 3. I just It just happened numbers are by absolute value the same. It just, and signs are opposite, and looks like I switched. I didn't switch. I just flipped the sign for this negative 3 and 3, okay? We flip only for the negative 2 and 4. So because this the whole piece is equal 1, that means the inverse is going to be 4, 3, negative 3, and negative 2. Okay, so once we found the inverse, we are moving ahead and multiplying this inverse of the coding matrix by this coded message, negative 29, negative 64, and so on. So let's do it. Since it's a main operation now, I'm going to write down in blue color so you can see. 4, 3, negative 3, and negative 2. And we multiply by negative 29, negative 64. So multiplying by inverse to get original matrix, okay? 43 and 92. And result, we are getting 4 times negative 29 plus 3 times 43. Here will be negative 3 times negative 29 plus, I will minus, actually, I will place at the end of this video, I will place the reference to multiplication and inverse, okay, of matrix. Minus twice 43. Okay. And now the second column, 4 times negative 64. Here we have plus 3 times 92, negative 3 times negative 64, minus twice 92. Okay, and our result is going to be 13, 20, 1, and 8. Here it is. I didn't even multiply myself. I just wrote down the original one because I'm absolutely positive that this is going to be result. Okay, we got this code 13, 1, 20, 80. Let me write down 13, 1, 20, 8. Now we can go back to our alphabet and find which letter is matching to our 13, 1 and 28. So if you go by alphabet, so 13, it's going to match M. 1 is going to match A. 20 matching T. And 8 is matching H. The problem is solved. We decoded, encoded, and decoded the word. Okay? Okie dokie. See you next time.